LTX 2.3 models have been released, and according to their website, the latest models are better at generating fine details, better prompt understanding, improved image-to-video generative capabilities, a clearer audio than before, and supports portrait view. The audio is definitely clear in the video I generated just now using the 4060 Ti 16GB GPU. On the GitHub repository, links to the latest models are provided. So these are the checkpoints, which may contain the diffusion model, text encoders, and the VAE. The dev version you see here is the largest 16B model, and this is the distilled version of the same model. The difference is that the dev model will produce results in around 20 sampling steps, with a CFG value around 4 or 5. In comparison, this distilled model will do the same in 8 sampling steps, with a CFG value around 1. Next is the upscaler, and this is how we saw in the previous LTX workflow. A 2-stage process was involved in generating the final result. The second stage used a similar latent upscaling model. This file, here it says it will be used in some future implementation, which I am not aware of. Next is the Distilled Lora. This Distilled Lora can be used with a dev checkpoint, and then you can generate results with lower CFG and sampling steps. The models can be downloaded from HuggingFace, and this model card has some more details if you want to know more about the model and code. Here, the model checkpoint details are similar to what we saw, and we need to look for these 3 files. Into the File and Versions tab, this is the dev checkpoint, which need higher sampling steps. The file size is around 46 GB. You can try with a 24 GB card. I think ComfyUI should manage if you have enough RAM. And then the Distilled Lora, which can be used with the dev model above. The Lora file size is also large, so you will need at least 24 GB GPU with a good amount of system RAM to make this combination work. Next is the distilled checkpoint, and as I said before, this will produce results in 8 sampling steps without the help of a Lora. The file size is large, but similar to the dev checkpoint, this is due to the BF16 data formats. And below are the upscalers. So this is my messed up workflow, and it looks bad because I was trying to make it work on a system with smaller memory. To have it work, you will need to update ComfyUI. Go to the update folder and run this update batch file. There are constant updates being pushed, so if you are enthusiastic and unable to wait till the nodes become stable, I suggest you update this every 6 hours for the next 2 to 3 days. After the update, go to the template section and here select the LTX 2.3 to apply the filter. Then you should see the workflow available for the model. Image to video is on the left and text to video is on the right. Click to load the workflow, and these are the files this workflow is asking to download. The files are large for my 4060 Ti 16GB system, so I will not be downloading. The workflow looks clean, but I have to make a few small changes. A few nodes are removed, and these red-colored nodes are added instead. Instead of the large 41GB checkpoint, I'm using this smaller FP8 distilled transformer. Kajai had uploaded and updated his repository a few minutes ago. And inside the diffusion model folder, there is the transformer, which is a BF16 file. This is large, so I am using the FP8 transformer. Save this file in the diffusion model folder. To begin, load this text-to-video workflow. The files you will need are given on the left. Not this checkpoint, but you can get the latent upscaler, the distilled Lora, and the text encoder. And then unpack this subgraph. Inside, this checkpoint node and other nodes used to load the files are removed. I will be giving the workflow in the description. This was just for beginners. This low diffusion model will load the FP8 transformer. And then in the same repository, you should get the text encoder save it inside the text encoder folder, and select it here. This Gemma 3 file can be downloaded from the link given in the workflow. Next is the video VAE. It goes in the right with the help of this rerouting node. This load VAE node is from KJ Nodes. You'll need to update the node to make it work. Inside the ComfyUI Manager, search for KJ, and this is the node group you should update and restart ComfyUI. After that, we need the same node to load the audio VAE. Both the VAE can be found in the repository inside the respective folder. In the workflow, there is this prompt enhancer. Type the prompt here, and then this will output a detailed prompt for the LTX model. You can have it connected like this, but I'm not using this because it is very slow. Earlier, I said that the LTX workflow processes the video in 2 stages, so this is the sampler stage 1. The output from here goes to the second stage above, with the positive and negative prompts. Here, I've added a few nodes after stage 1. This will take the output, and then it decodes it using the audio and video VAE to get the result after stage 1. This stage 2 has a Distilled Lora with an upscaler. Right now, I am using the Distilled Transformer. Using this Lora with it will spoil the result. So I will bypass the node to avoid the problems when using a distilled model. You can use it with a dev version of this transformer. The nodes I added are here, and these are a few prompts from the internet that I will try and see the result. First, I will keep the default prompt, which is about a puppet girl singing, "It's raining." The changes you need to look for are the number of steps in CFG for distilled models. In the second stage of this workflow, I will avoid running this section in one go because it may fail after some time. I will run the workflow. I got the result after 147 seconds. One iteration took around 10 seconds, which is faster than before. I also increased the total frames. This should generate a 10-second clip.
It's raining, it's raining. I love it when it's raining.
The result was okay. But the song in the prompt was actually for a 5-second video. Increasing the total frame made the song slower so that it covers the 10-second length. Now, I will try using the second stage. And if you wonder why this node is not active, it is because I am using the tiled VAE decode. You can use this if you have a bigger graphics card. As said before, I will bypass this because I am using the distilled model. Now it should work. The second stage processing was slow in comparison to before, and this is the result.
It's raining, it's raining.
It looks bad. There must be something wrong, which I will be looking at later. I will use another prompt, bypass this section, and run the workflow. It took 126 seconds, and this is the result. Well, that was straight from Game of Thrones. I will download this devfp8 transformer model and place it inside the diffusion model folder. Then press the letter R to refresh and select the model. The number of frames will be as it is, but the number of steps needs to be increased, and the CFG as well. You can try a different sampler, which should affect the result noticeably. I will run the workflow. It took 398 seconds, and the result generated looks bad. This workflow was made with 2-step process, and I am using only one. Maybe this could be the reason. I will do some more tests after this video, and then I will post an update. For now, I will try a few more prompts with a distilled model and different samplers. The distilled model generates results faster, which allows generating multiple videos with different settings. The video is okay, but not as clear as the Vram 2.2 model. The audio is definitely better than before.
Oh, wieder papaya. Där följer jag dig. Kishwija.
Now let's check the image-to-video workflow quickly. Unpack the subgraph. Copy the node from the older workflow and paste it into the image-to-video workflow. Remove the nodes for loading the safe-insert files. And remove the second stage processing. I will use the video create node after the stage 1 processing as I did before. So, this is how it looks now. I need to replace the connection from these nodes so I can use the transformer instead of the checkpoint in the stage 1 process. And this is where I will upload the image. I have made the connection to make this section work. I will bypass the second stage. And now I will upload an image and then paste a prompt about an astronaut hatching from a fragile egg. I will also decrease these values because I'm using a distilled model. The total number of frames I will let it be as it is, because previously the rain song in the prompt was short, but due to the longer video, the song spoken got stretched to cover the length. The video generation was fast, and it took 67 seconds. And this is the result. I am generating 720 pixel clip in 50 seconds. So that is a quick video on LTX. I will make another video on the GGUF model next. I hope this video was informative or useful, and I wish you an excellent day.